All right, hello everyone. Um, Today's lab is about ANOVA. So I'm going to go ahead and walk y'all through this. I need you to turn in exactly what I'm going to do. So the assignment in this case is to watch this video and enter the information along with me. A heads up is that the numbers are going to be random, so your answers will vary from mine, but as long as you follow the exact procedure, you should get the model, and you should be able to turn it in for a good grade. So first of all, we're going to do, we're going to go to this private only to me part up here. Click it. We're going to make this, anyone with a link can access it. Hit done. This allows you to turn in the homework assignment. So what we're going to do here is we're going to hypothesize, we're going to form a hypothesis. And this hypothesis is going to be the older, the older you get, the more back pain you develop. Okay, and this is what you call a one-tailed hypothesis. Let's go ahead. So with that being said, we're going to do ANOVA, and what ANOVA is it allows us to compare variances and averages across multiple groups. So it's kind of like a t-test, but you can do it with more than two groups. So we're going to do a 18 to 29 bracket, a 30 to 39 bracket, 40 through 49, and for our fourth group, we're going to go 50 and older. Okay. So now we have four groups. What we're going to do is we're going to generate random numbers to fill in this. In order to do this, it'll be your rand between. And because this is a younger group, I guess I should talk about what we're doing here. Suppose that we each group went to the doctor, and at the doctor, you know how they have a how bad does it hurt scale. When you do the happy faces, it's like very happy is 0 pain, and then the very mad or angry or sad face is 10 pain, and then everywhere in between is it represents in between those pain measurements. So 0 being the least amount, 10 being the most amount of pain. How much pain are you in? So they went to the doctor, and the doctor asked them how much pain they were in regards to their back pain, and they gave an answer. So because I'm going to rig the data set, and you're going to rig the data set just a little bit too, we're going to have the 0 being the lowest pain and 10 being the highest pain. So we're going to do a random between 0 and 6 for the younger people. Okay. We're going to go over here and equal rand between. And because these folks are slightly older, we're going to go 2 to 7 equal rand between. We're going to keep this out. Slightly more older, we're going to go 3 to 8. And then finally, the oldest audience, we're going to have them all the way, we're going to have them at between 4 through 10. All right. Now the next thing is we're going to generate a sample size of, we're going to go all the way to row 22 here. So highlight the entire thing like so. Click and drag the box down to row 22, and it'll generate your sample. Notice every time that I hit a digit, then all the numbers will shift and change and all that stuff. So the next step is we're going to make sure that doesn't happen. So we're going to highlight the entire thing, right-click, copy, right-click, paste, special, values only. Now what that does is now the random numbers are locked. It no longer changes. Now the next step is you're going to go to the extensions and add-ons. You're going to get add-ons, and you're going to go with the Excel Minor Analysis Toolpack. Click that. Click this, and then you're going to install it. Mine says uninstall, but yours will say install. So go ahead and get that worked out. Put that on your machine. Once it is on your machine, go to your extensions here, your add-ons. And you'll see here, Excel Minor Toolpack. You just hit start. And you're going to go up and you're going to click ANOVA single factor. So the input range is going to be this to that, A1 through D22. We are grouped by columns because, as you can see here, every age is in a column. Our labels are in the first row. As you can see, our age labels are in the first row. And our output range is just going to be right here. At age 29. Now, with all that, we'll hit OK and fire it off. You'll see here it generated some stuff at the bottom. So, what we're looking at here is the amount of variance we have. We have a sample size of 21. This is, group 18 through 29, group 30, and so on. Each one had 21 people in them. If you add up all the scores together, you'll clearly see that the 18 through 29-year-old had the least amount of cumulative pain, whereas the 30 through 49-year-olds had similar pains, and the 50-year-olds had way more pain. And you can see what their average number is. The average number for the younger crowd was 3, 5, 5, and 7. And you can see the amount of variance in between. So on average, there were 3 digits between people's numbers, 2 digits, 3 digits, so on and so forth. You can go up here and take a look. There's a lot of 6 through 3s up here. So that being said, that is the summary. Kind of gives you the thing. So what we're going to do here is we're going to take a look at the p-value first of all. P-value is less than 0.05, meaning that we can actually reject null. P. It was trying to do an equation there. So you can reject null. So null hypothesis up here, we'll go back to our hypothesis. We'll close this out. Our null would be age does not impact back pain. So because we go down here and we see the p-value is under 0.05, then we can say, hey, we reject this statement. In other words, we can just completely reject this statement saying that age does not impact back pain. This statement is not true according to this model. So so the alternative is this statement is true. So the older you get, the more back pain you have. According to our data, older folks reported they had more back pain. Okay. So let's go ahead and look at the other numbers here. This is your between groups variance and your within groups variance. Your between groups variance is the variance that occurs between these groups, right? And the within group variance is the variance that occurs within the groups. Okay? So, one group and then adjusted across all groups. So, as long as these numbers are different, odds are you're on a good path. And you can see here the average variation between them. And you had a very big F and a small F crit. If this F is 5 points difference, in other words, let's say this was 18, then as long as there's more than 5 numbers difference between 2 and 18, then you can reject P. But this p-value tells you that already. So you can just look at the p-value. Is it less than 0.05? If it is, you accept your hypothesis. If it is not, you reject the null. You accept the null hypothesis. So your assignment is to duplicate what I have. Remember, these are random numbers, so you're not going to get the exact same answer that I got. And then report your findings. And that is the lab. I will see you on the next one.